Hello, good morning everyone, and I believe it's a sunny day out there for most of us. Welcome to our fourth Technical Tuesday for ECA members. Mike Smith, Technical Director speaking. We have a lot of members signed in today to hear about our presentation on EICRs. And so therefore it might be that some of you are joining for the first time and listening to one of our Technical Tuesdays. So I'll just explain that we are keeping our cameras off, and that's not because we're hiding, but we're all working from home, different connections obviously, so we want to preserve as much bandwidth as possible. All microphones are off except for the presenters. If you want to ask a question, please do. Just open the QA pane, so it's like a chat pane. Type in your question, and we may answer as we go along the presentation. If it's something really important, we might stop the presentation and deal with it, or we'll wait till the end where we've got 5 or 10 minutes Q&A. Gary Parker, Luke Osborne and myself will monitor the questions as they come in. So I think that's enough for precursor. I'll hand you over to Shahid. He's going to give the presentation today. So good morning, Shahid.
Morning. Thank you very much, Mike.
Okay, over to you.
Cheers, thank you. Good morning, everyone. Welcome to this presentation on EICRs and appropriate coding of electrical faults. My name is Shahid Khan, Technical Manager for the ECA. Today we'll introduce the subject of EICRs and coding and why it is such a popular topic. We will look at the fault codes and what they mean, the consequences of awarding a code to an item, what to do with non-BS 7671 items, a word on inspection and testing, and finally how we at the ECA can help and support you. Introduction. I know that most of our members have a good grasp and understanding of inspection and testing, so hopefully this presentation will be a bit of a refresher for you. BS 7671 introduces 6 reasons for conducting periodics or condition reporting, as it's now called. These are for the safety of persons and livestock against the effects of electric shock and burns, protection against damage to property by fire and heat arising from an electrical installation defect, confirmation of the correct rating and setting of protective devices, providing adequate protection against electric shock, confirmation of the correct rating and setting of monitoring devices, confirmation that the installation is not damaged or deteriorated so as to impair safety, and finally the identification of installation defects and non-compliances with regards to the requirements of 7671 that may give rise to danger. The subject of EICRs or periodic coding is quite a common question asked on the ECA Technical helpline, with members asking for advice as to the correct level of code to apply for certain items under investigation. It is important to note that this process is not an exact science, as the level of risk to safety of an electrical installation depends on a number of factors, including the type of installation, be it domestic, commercial, industrial, or a special location perhaps, the age of the system, the availability of previous documentation, the quality of the record keeping, and more, which all have a bearing on the level of risk to safety. The inspector who is immersed within the inspection and testing process is best placed to make that judgment, as they are able to use all the senses and see the issue firsthand. We will try and provide guidance within this presentation to hopefully give you pointers and tips to think about. It is also worth mentioning that the workload in terms of periodics is about to increase over the next couple of years with the advent of the electrical safety standards in the private rented sector regulations 2020, which is coming into force in England on the 1st of June of this year. This topic has been covered on a previous Technical Tuesday webinar. Just a side note there, all the webinars are available on the ECA website and via our ECA YouTube channel as well. It is impossible to cover all the ins and outs of periodic inspection and testing in a single webinar, so we must point out that there are a couple of really good industry guides that we would urge you to read and familiarise yourselves with. The first one has to be the IET's Guidance Note 3 on inspection and testing, and as shown, the ECA are a contributor to the text within. This guide is brilliant as an overview of inspection and testing and does bring up the idea of fault coding in Chapter 3. However, the level of detail with regards to coding is a little sparse. Hence, this second guide that's worth mentioning. It's a no-nonsense, non-biased industry guide. Best Practice Guide 4 produced by the Electrical Safety First. It is a free download via the link provided in the presentation. It must be said that there are many other guides and publications on the market which tackle the subject of inspection, testing and coding. However, not only can they be expensive to purchase, but could not be considered as non-biased industry guidance. The fault codes. So a C1 code is an item which indicates danger present, risk of injury and immediate remedial action required, also known as immediately dangerous. Basically, as the item currently sits, it is already dangerous and must be acted upon. No secondary process must occur to make it more dangerous. Another way of looking at it is that the item under investigation is an example of a failure of basic protection exposing live parts, which need to be live to perform their function. Code C2 is reserved for items which are potentially dangerous where urgent remedial action is required. Possibly the hardest to contextualise without further explanation. What does the word potentially actually mean? Basically, these items would become dangerous if another issue or fault occurred. When processing the level of risk, the question you need to ask yourself is, if a fault occurs, would this item lead to a dangerous situation? If the answer is yes, then we are dealing with a C2 fault. Code C3 items. These are such that do not impair the safety of an installation. Think of the language that's been used. No longer do we have the word dangerous in the definition, rather it's a recommendation. The level of fault has to reflect the nature of the language used. What I would say though is that code C3 faults can sometimes be the hardest to place a regulation number against, as they are potentially the most subjective of items and personal pride and working practices can cloud an inspector's judgment. For example, if the terminations within a consumer unit or distribution board are messy and the installer has not taken their time to make it look as good as you or I would, but the terminations are all secure, there's no excess copper showing and the cores are colour coded correctly, what should you do? Do we code it or not? If the issue is aesthetic alone, I wouldn't code the item. However, some inspectors would point to regulation 134.1.1 and emphasise the good workmanship element of that regulation to justify the code. Hence the subjective nature of periodics at times. Neither are necessarily wrong, depending on the scope of works agreed with the client. Code FI. Further investigation is not as common as the three main codes previously mentioned. However, can be used when it may not be possible to pinpoint as to the source of the fault, or when the inspector needs to look deeper into deciphering the severity of the item under investigation. Also, it's worth pointing out that the full name of Code FI is Further Investigation Without Delay. So this added time element gives the inspector the nod that the item under investigation is dangerous. And the question is more as to the level of danger, be it either a C1 or a C2. What code would you give it? Let's take a look at some pictures. Just for a bit of fun, can I ask the technical team and the participants of the webinar to give us your judgment on the pictures that follow? Feel free to type in whatever code you think each of the pictures deserves. So here we have a funky old light switch that perhaps some of the older members of the technical team remember installing. Gary, what code would you give this?
Did you just pick me because I'm old?
Sorry.
Oh,
Gary, it was only because he didn't want to pick on me because I'm older, but I'm his boss.
sorry, Shahid, I couldn't quite hear you there. My hearing trumpet wasn't plugged in. Did you say what code?
Yes, please, mate.
Oh, well, it's broken, isn't it? So you could be able to poke your fingers in. So that's got to be a bit dangerous. Oh, we've had a comment come in from somebody saying it's a C2. Is it a C2 or is it a C1? Do you think, if we've got access to live parts there?
Gary, if it was just a crack and that wasn't missing, would you then look at that as being a C2? But because you could actually stick a finger in, we're now getting into danger and current danger.
Oh, well, I wonder what happens if the slide moves on.
C1. Yeah, that's it exactly. It's a failure of basic protection. You can basically stick your finger in and you could touch a live part that's supposed to be live. In terms of regulation number, it contravenes 416.2.1, which is the one that talks about the IP requirements on the various surfaces of barriers or enclosures. What about this one, chaps? Would you say it's similar to the last one?
I think there's a little bit of a delay on the presentation. A raft of C1 codes came in after about 30 seconds. Give it a few seconds and a few people will comment here, no doubt.
Yeah, there's a lot of C1s coming through that first one. Absolutely right. Yeah.
There's a few things there, aren't there? There's the whole breakage and yeah, whether you can get your fingers in, what can you touch.
Is there something missing there, Shahid?
There is. So I've gone with a C1 for the obvious defect in terms of the failure of basic protection. But there's also a screw missing. I know a lot of people have said that I've got a screw loose, but this thing definitely has. You know, on the left hand side, you can see that clearly it's not secured correctly. Hence why I'd also give it a C3. In terms of regulation numbers for the C1, it's the IP requirements again, so 416.2.1, and for the C3, it's good workmanship for me, so it's 134.1.1 in that case.
Obviously, Mike and I couldn't see that missing screw because we don't have our glasses on.
We did have a wealth of responses on that one. A lot of people putting in C1, many things. A couple of people said for C2. So yeah, it's interesting to see this presented.
What about this one? So ignore the fact that it's a consumer unit that's floating in thin air. What is potentially missing?
Stickers, labels?
Yeah, I was going to say, it looks far too attractive. It should have lots of yellow stickers on, shouldn't it?
Yeah, that's right. So the fact that the periodic inspection notice, RCD functional test button notice is not there, and the circuit schedule is missing as well. So,
also, what's it made out of?
It's made out of a combustible material, i.e. plastic. Yeah. Another C3. What about this one? So that's the connections to a downlighter that have been made off with a bit of chock block. What do we reckon?
I'd go for a C2. I'd say for that one.
Yeah, I'd agree with that. Yeah. So the connections are not adequately enclosed. Regulation number wise, it's 526, 526.1 or 526.5 would work in that instance.
Just Shahid, there's a point just somebody's made. Would you put the worst code for multiple faults, or would you actually put a fault for each separately?
Personally, I'd list every single fault.
Okay.
So
and
if there was multiple faults, I'd list each fault and code them appropriately.
Even if the worst fault, when that was fixed, would solve the others.
No, in that instance, you might as well just give it one. Give it the worst fault, and that's it. Because yeah, Yeah, and in that instance, it'd just be the worst fault.
Okay.
Yeah. What about this picture? There's quite a lot wrong with this one, isn't there?
I was going to say, where do you start?
Yeah.
Mixed breakers and yeah.
Conductors wrapped around buzz bars. It looks like there's a neutral as well that's wrapped around the buzz bars. It looks blue to me.
So wrong cables. Mm.
So a raft, you could potentially pick up a C1, C2 and a C3 all in one picture there.
Somebody's just put too many to mention. I think he's hit that one.
I'd agree with that. What about this one?
That's fine, isn't it?
Yeah,
It's not very obvious there, is there?
It's a bit dusty.
Yeah, and the old wiring colours. If we ignore the old wiring colours, can
Not
anyone?
that old, Shahid, not that old.
What about now?
Ooh.
Ah, a bit of overloading on one of the phases.
Yeah. So not all faults are visible and may require a degree of non-invasive testing via a thermal imaging camera. C2, potentially dangerous, risk of overheating and fire as phase 1 is burning hotter than the others. That's what I'd give it. The consequences
if somebody saw that and they're not really sure why that's happening, there's nothing obvious in terms of a loose connection. What about an F coding?
Yeah, that may be appropriate. Yeah. The idea with an FI is it's to be used where you're not exactly sure as to why it's caused a problem, but you know it's a dangerous condition. So yeah, FI could work in that situation. Yeah, without a doubt. Yeah. The consequences of awarding a code. So any C1, C2 or FI codes awarded on an EICR deem that the installation contains dangerous elements, thus is unsatisfactory. Whereas awarding a C3 code alone does not necessarily mean that the installation is unsatisfactory. It doesn't mean it's unsafe. In other words, if I was to do a periodic of, say, a factory, and I found 1 C1, 2 C2s and 12 C3s, the installation will be unsatisfactory. However, if I only found 12 C3s, the installation will be satisfactory and fit for continued use. Okay, it's only C1, C2 and FI that fail an installation. EICRs are a snapshot in time and are another example of risk-based analysis within the electrical industry. Similar to an MOT on a car, the electrical installation is being assessed to ensure a minimum standard of safety is achieved. The inspector is using their judgment to assess the level of risk to safety for the building users created by any electrical defects. Coding of electrical defects should not be subjective or emotive decisions. Instead, they must be based on BS 7671, and if any decisions were ever challenged, the inspector should be able to point to a regulation which is being broken by the item under investigation. Therefore, periodics should only be carried out by individuals who are competent in assessing risks, fully conversant with the requirements of 7671, and familiar with the type of installation under test. The ECA have developed this simple decision tree. It's available within one of the guidance notes, and it helps members to come to an answer with regards to which code to provide an electrical defect. So if we follow it through, so a perceived defect is located. Does it present an immediate danger from shock or fire to the persons using the installation? If the answer is yes, you would award it a C1. If the answer is no, it leads you to a second question. Could this defect become dangerous if a fault or other foreseeable defect was to occur? If the answer is yes, it's a C2. If the answer is no, it's a C3 and consider upgrading the installation. To fix or not to fix? This is a common question on the helpline and also in industry. When conducting a periodic and you come across minor faults that you've fixed as you've been going along, Should this information be recorded on an EICR? Technically, the correct answer is no. The EICR is simply to comment on the current state of the installation, and if some of the items have been fixed, they no longer are an issue, so shouldn't be commented on. But what is the best way to capture this valuable information and justify your time to your client? Until now, there was nothing available to record this information. However, we've developed a post-EICR assessment completion form, love the title, for our members to capture this information for their clients. This will be available on the ECA website within the next couple of weeks. Okay, so it's gone through the final version. It's just about to be published on the website. Non-BS 7671 items. This is another common question that people ask. It's what do you do with non-7671 items? So, for example, while conducting a periodic inspection, you notice an issue with the emergency lighting provision of a building. This defect actually falls out of the scope of 7671, so shouldn't really appear as a defect on an EICR, as the emergency lighting provision is covered by a different standard entirely, 5266. It is, however, best practice to bring issues such as this to the attention of your client to aid in achieving a much safer installation overall. Inspection or testing? The truth is, both are required for effective periodic inspections and tests. However, what tends to happen is that the inspection process is glossed over and treated as a poor relation rather than a 50-50 partner. As we saw earlier, many of the electrical defects can be spotted via inspection alone, and more time needs to be dedicated to this process. Just a few pointers here really, and things to consider. Firstly, be clear about the extent and limitations of your condition report as agreed with the client or the client's rep. Everybody is quite content at the fact that an inspector must be a skilled person electrically to be considered competent. But why is the familiarity with the type of installation important? The reason it's important is it's in order to limit the level of risk you expose yourselves to when undertaking periodic inspections and completing EICRs. For example, if you take a person who solely works on domestic dwellings and ask them to undertake a periodic of a factory, their judgment will not be as accurate as somebody that works in factories on a daily basis, as they are looking at a factory through domestic dwelling lenses. And it's a vice versa situation. If the positions were reversed, the person that works in a factory would not have the same appreciation of a domestic dwelling either. A couple of other points to mention are that you should always ask for previous documentation regardless of the type of installation. The quality or lack of records will also give you clues as to the current state of the electrical installation and what to expect. And for complex installations, it's always proven beneficial in my working life to take the time to undertake walk-around surveys of installations before starting the periodic. It gives you a chance to make sense of the installation, decide on a plan of attack, and highlight any areas that you may want to focus on. I tried my best not to mention the dreaded times we are living in. However, from a periodic inspection point of view, this may be a blessing in disguise. As the vast majority of people are either furloughed or working from home, a lot of buildings and workplaces are empty. This would therefore be an ideal time to perhaps increase the level of in-depth inspection and testing that would usually have to wait for annual shutdown periods. The last couple of bullet points were only recently added to the presentation following a query that came through on the helpline where a member was finding it difficult to explain to non-technical clients as to the need for periodics. They were under the impression that perhaps this was an optional activity rather than something that really is mandatory. Regulation 4 of the Electricity at Work mentions that all electrical systems must be maintained so as to prevent danger. And Regulation 29 of the same statutory document effectively calls for the duty holder to provide their own defence. So, if the HSE was to investigate an installation following a serious incident, the burden of proof would be on the installation owner to prove that they took all reasonable steps and exercised all due diligence in maintaining their electrical systems to prevent the rise of danger. Hence, where record keeping of regular periodic inspections is crucial in providing that defence. And then the final section, how can we help? So as members, you're all aware of the numerous benefits that membership brings. Some things to highlight, the technical helpline, free business and legal helpline, and access to a library of relevant British standards. We also provide numerous technical guidance notes, technical bulletins, application guides, and the like on a variety of topics. We input on various industry codes of practice and represent your views at the IET and BSI committees. In summary, the inspector is best placed to award a code. Always have a balanced approach and think of the consequences of awarding a code. Can a regulation number be attached to the fault, thus removing any bias from the decision? EICRs are only to be used when checking against BS 7671. Inspection is just as important as testing, if not more. Now is a great time to undertake in-depth EICRs due to the COVID-19 situation. And finally, we are here to help our members. Just ask. Any questions?
Thank you, Shahid. That was very, very useful. And when Shahid was asking about those codes, I can assure you it wasn't practiced. So it's the first time I've seen this presentation today. You said now is a great time for conducting EICRs. What did you mean by that?
So the fact that the vast majority of people are either working from home or are furloughed, it means that a lot of these premises are empty. Today on the news, for example, there was an interview from the guy, technical, I think he was a general manager of Vauxhall. So that entire plant is shut down over this lockdown period. That's a brilliant time to conduct a periodic inspection. You know, you can get in there and you can see the nitty-gritty of it and actually do what you need to do.
Yeah, absolutely. I mean, I think for those employers that have planned maintenance or even refurbishment work, it's an ideal opportunity to get some of that work done now before all the workers are back at desks, even if that's in a sort of distance way and half the workforce there. It seems to be the obvious time, absolutely. And I suppose really simple things like RCD testing. When do homeowners and building managers actually get to do those? We've seen it many times that it just doesn't happen.
Yeah.
Okay, thanks for that, Shahid. Gary, can we have a look at questions and maybe highlight some of them or pick some up?
Oh, we've got loads, absolutely loads. I've been trying to reply to them, so
yeah,
we've had loads of really good ones come in. Some people have been asking about that post EICR form, which is really good. Hopefully that'll be on the website shortly. There's a fair bit on mixed switchgear and breakers in boards, which we've covered off a little bit. The ESF best practice guide typically raises that as a C3, but if there's any signs of heat damage, the breakers being jimmied in, then yeah, absolutely knock it up to a C2 at any point. The little slide Shahid showed with the decision tree was very pertinent, because there was a question earlier on about ECA producing a guide similar to a code breakers book that some other organisation, I can't remember, produced. We probably won't, because we already contribute, as Shahid's mentioned, to guidance notes, the best practice guides, and to make another one is not something that we're going to really enjoy, because we're not in it for profiteering, and also our members cover such a vast array of work. To have a C2 in a dwelling, it might have the same problem in a factory, but it might be a different code. So it's quite hard to cover them all. But the decision tree that Shahid showed should hopefully give you the ability to consider any code and the best practice guide. Something just worth pointing out, that ESF best practice guide is free. And as there's a few Yorkshiremen on the webinar today, we like free. Hey, we're all in it. It is aimed at dwellings, but as a reference, it's pretty good. It's pretty fine. If it's a C3 in a dwelling, it's not going to be any more than that in a controlled building. So it's a really good point to call for any sort of installation. Yeah.
Yeah, no, I'd just echo that statement, really. The fact that we contribute to industry guides makes more sense than producing a book for profit. It's not going to do ourselves or our members any justice in doing that.
Okay, Shahid, Gary, just one from me. In terms of older installations, let's say pre-15th edition.
When was that? 1950s?
And you won't even remember those days, actually. You've had an installation. It's fine. It's not been altered, butchered too much over the years. It's continually got, C3 recommend that the installation's updated. At what point do those old installations become a C2? What's the trigger?
Was that for me, Mike?
For you or Gary, or just a discussion point?
Well, to be honest, if all the ZS values are coming out okay, you've done your inspections, everything looks fine, everything complies in terms of automatic disconnection, then to be honest, just because we've got old wiring colours and old gear, if it's not unsafe, do we have to upgrade it? That would be my point.
Okay. So what you're saying is you're looking for deterioration of cable insulation and accessories.
That's right. Anything that impairs safety needs to be acted upon. That's how I'd look at it. There is also a note in BSM 671. I think it's note 2 that's part of chapter 65, and it mentions existing installations may have been designed and installed to conform to previous editions of 7671, applicable at the time of their design and erection. This does not necessarily mean that they are unsafe.
Absolutely. Okay, thanks for that, Shane. I just want to pick up on one that Eddie's picked up, and it's one that we've probably heard of before, but it's a really good point. Advice for building operators and homeowners is that RCD testing. Test your RCDs when the clocks change. Yeah, it's a very useful memo to yourself.
And just picking up on what Shahid there mentioned, just because something's old doesn't mean it's unsafe.
I wasn't talking about you, mate.
Well, it was just my knees more than anything. But there's plenty of installations out there, larger installations in particular, hospitals, schools, London Underground, Severn Trent and Thames water sites that are absolutely electrically safe, solid and sound. They're just a bit old, and just because something is old doesn't mean it's unsafe. It's the key principles of can you get a shock from something, not what is the cable colour.
Yeah.
Okay, is there Luke or Gary, is there anything else that you want to pick up off the question and answers? It might be worth pointing out before you do that If there are any that we don't get time to look at or we haven't answered fully enough, we will answer all the questions and publish those.
There's still a few questions out there. We had, hang on, where did we find it? Can RCD protection for old installations be C2 rather than C3 coded, or would justification be required?
It would depend on the scenario and what it's doing. Context. Yeah, but it certainly can be if it's necessary. But if it was just there for offering additional protection for a cable in a wall, most of the time it's going to be a C3.
Yeah. Okay. And another one. One of the viewers has written, I often write a separate letter to go with the ECR to stress the urgency of the observations, as often the reports are just not looked at. Are there any other suggestions on that to save these things getting ignored?
You can lead a horse to water, can't you? But if a client employs you to undertake an EICR on a building, it doesn't mean that they're going to do anything with it. I mean, the pictures on the screen now show some real life, genuine existing installations, and somebody's gone in and done that and not thought about it. The one in the top left, at what stage did somebody put another meter and another cable in before they thought, hang on, I might just leave that? It's one of those things that certainly with the private rented sector legislation that Shahid mentioned is going to be tightened up. Insurances are going to be tightened up. The clients' requirements are going to be tightened up. But from an electrical industry point of view, it's very hard to force somebody to spend money. We can only tell them where it's wrong. If they choose to ignore us, on their head be it.
Yeah. Yes, there's limitations on how far the installer can push the client. We've got a couple of other ones. What happens when you have a C1 that would require isolation of a circuit to ensure safety, but the client refuses due to interruption of the business, for example? Would a danger notification suffice in this case?
It's similar to the last question. If you've issued a C1 and the client won't do anything about it, you can't really do an awful lot with it. We do have a separate certificate for electrical installation danger notification, which is available free for ECA members. It's just a one-page form that you get the client to sign. It wouldn't necessarily do an awful lot for them, but it's very different when you've got a client and you're speaking to them to say, this is wrong, they can dismiss it. But if you say, this is wrong, I wrote it on this bit of paper, would you sign this now? Often that makes them, oh, hang on. Yeah. So yeah, it's a really, really good approach. In many cases, we've got to be honest, a lot of the clients are non-technical. They see a box of ticks and crosses and a load of numbers. If they're a non-technical client, break the condition report down to them and say, these are the things that are wrong. It's a C1 because it's very likely to hurt or catch fire.
Yeah, your obligation is to immediately inform the customer of a dangerous condition. So if you've done that in writing and they've signed it, then effectively you've done your job. If you step over that mark and then you go down the route of isolating, then you get into the nitty-gritty of, well, if they've lost X thousands of pounds because this piece of equipment has been isolated, who pays for that then becomes a question. It becomes a bit murky from that point onwards. So really your obligation is to immediately inform the customer of your observation and leave the judgment, leave the recompense to them from that point onwards.
Like you mentioned earlier in your presentation, Shahid, it's down to the owner of the installation to prove that
they've got to prove their defence
as possible. Yeah,
that's right. Yeah,
I think it's worth pointing out to anybody in that situation in a workplace that they are subject to the electricity at work regulations as well.
Yeah,
which is a legal requirement.
Guy Taylor's just put a good point in there. He would often write a separate letter to go with the EICR stressing the urgency of the observations as often the reports are not looked at. And it's absolutely right. When you see all the boxes, all the numbers, people just fog over, especially non-technical people. All they're interested in is the satisfactory or unsatisfactory element of it.
Yeah.
Okay, one other one from Julian. He says, if the installation is unsatisfactory, what would you enter as the retest time? Any guidance on that?
If you look at that section clearly on the form, I think that retest time is after remedial action has already been taken. So when you put that time in, they've assumed that somebody's gone in and fixed it. It's the time after it's been fixed is what you're indicating on that form.
So are you saying then that you've got to rely on the general condition of the installation as a whole and not particularly focusing on a particular C1 there?
Yes. Yeah, because that box that's on the form, it's basically, can't remember the exact wording, but they're assuming that you fix the faults. It's when would it next be tested after the faults have been fixed.
Thank you.
Okay, we've probably got time for one or two others to pick up. Is there anything else?
There's one here from Paul. I've encountered at least one installation with the odd MCB installed upside down. What are your thoughts on this?
Was it in Australia, Paul?
I was waiting for that one.
I don't believe the orientation of the breakers affects the way they function. Might look a bit silly, but unless the manufacturers say you can't do it, electrically they should work perfectly fine.
For quick identification, I guess that's probably more the issue, isn't it?
It looks a bit silly, and you've got to ask why. But you know, I was speaking to a guy who wanted to fail a domestic installation because the board was sideways. 3-phase boards have sideways breakers, so it doesn't impinge on the safety of them. Might just look a bit silly.
Okay, thanks.
Oh, we've got a good one here from Gary about main bonding cable size can be an issue. Again, going back to the ESF best practice guide for your bonding, if there's nothing whatsoever, none being put in, and it's needed, that's a C2. If there's something in and it's adequate, that's showing no signs of stresses, damage, thermal damage, etc., that's usually a C3. I'm guessing Gary at 11:42 AM was talking about PME installs with a 6mm bond. Quite often that's a C3, unless you can see any signs of harm. If we get 10 more questions, we'll have broke 100. I might put one in.
Wow.
This is the most popular presentation we've done by about 99 questions so far.
Okay, well, while we're sort of thinking about another question to pick up, Shahid, just what are your thoughts about often in terms of doing an inspection, you can't be intrusive, but you may suspect that there are a number of joints or joint boxes under floors, above ceilings, etc., which are inaccessible for access for maintenance, etc. What are your thoughts on that? You suspect, but you don't know.
Yeah, it's always a worry when that occurs. I do believe, though, on the condition report itself, that checking under floors and in loft spaces and stuff like that I think it's considered a limitation, unless agreed previously with the customer. So you're kind of taking it on. Basically, if it's a difficult one, it's a difficult one because you can't just say, oh well, I just ignore it because it's a limitation anyway. Because you wouldn't. You try to do the best job possible. I would raise it with the customer if it were me. I'd raise it with the customer and I say, look, I need to do a bit more testing of this installation, and see where they're willing to go with it, how movable they are on price, and how amiable they are in terms of that to accommodate that. That would be the way that I would tackle
that. Okay, interesting.
Gary, what do you reckon?
I was just looking at that picture of Mike in his paddling pool there. Yeah. I mean, unfortunately, we don't have X-ray specs, do we? So we can't be held liable for anything and everything. We're given an overview of the installation in terms of its electrical safety with an inspection and appropriate tests, but we're not dismantling the whole installation to access everything. It's just as best as we can do.
Okay, thank you. It's these grey areas that often cause the most debate, obviously.
Yeah.
Right. Okay. Are there some more that we want to pick up?
We've got one from Paul here saying long main bonding cable runs, 25 meters of 6 mil, continuity in excess of 0.05 ohms. Would you leave this as a C3 or would you make it a C2? Very specific, this one.
Yeah, sounds like it's off a particular job, perhaps. That 0.05 ohm figure is aspirational. It's not mandatory. The point of bonding is to equalize the voltage. It's not to carry a current. So the 0.05 figure is just a useful guide. If you've got something in excess of that, then as long as it's not looking ridiculous, it's likely to remain as a C3 for me. There's bonding there. It might not be currently up to date in terms of sizing, but I suppose with the size, and I think it changed on PME from 6 to 10 in around about 1984, 86 time. And if you were working 6 months beforehand, you were putting 6 mil in. If you were working 6 months after, you were putting 10 mil in. You wouldn't, in inverted commas, fail your own work on that sense. It would just be, in almost all cases, a C3 unless you can see any signs of damage.
Okay. We've got another one from Eddie. Well, first of all, he asked if... Okay. First of all, he asked if Gary was getting the beers in, but I don't think that's a pertinent question. So we'll go to his second
does Gary ever get the beers in? I don't know.
Yorkshire, still classed as Yorkshire Middle.
But his second question was, if you have lots of C3s on a form, would this still be satisfactory?
Technically, yes. But again, it's up to the inspector. If you've got a pair of C3s, they could add up to becoming a C2 all of a sudden. So a lack of an RCD for lighting circuits in the bathroom, C3. Lack of supplementary bonding for circuits in a bathroom on its own would be a C3. The pair taken together, well, that's two elements of danger. The risk has increased. You've knocked it up to a C2 in that sense.
Okay.
Yeah, I'd agree with that. It's a risk-based analysis. You're judging the level of risk to the users. Yeah.
Okay, so the key answer is be as professional and as objective as you can be, I suppose.
Yeah.
Thank you. That's been a great participation, great debate. We will try and get round to answering all the questions as soon as possible and publishing those. I think we'll have to leave it there. We are running over time. It's been a great debate. So I would like to just thank you all really for your attendance, for your participation. It's been a really good event. Next week's presentation, I believe, is on PoE. And when we think about power over Ethernet, don't be fooled into thinking it's just about data. PoE is growing in terms of power capacity, and we're going to see a lot more of it. In the meantime, please give us any feedback that you want to, good or bad. It's all constructive. Visit the website if you require any guidance during the present restrictions, and we will be focusing much more on how we move forward really now into getting people back to work and safe practices on site. So thank you, stay safe, stay well, and hopefully we'll see you next week. Thank you.